with all the challenges to relational data the data model, there comes the so-called NoSQL data model to result in order to fix some of the challenges that facing relational database. Um, so there are multiple approaches to resolve these issues, right? All the challenges we face, the big data challenge and the schema challenge, asset challenge. So I make a quick list of what people have been trying all these years, since year 2000 at least. So the first option people choose is so remain within the relational database, the relational data model, but utilizing different approaches, such as the open source relational database model, the relational database management system, like MySQL and PostgreSQL, which can reduce some work and can be more flexible and easier to handle. Or you can use the cloud computing with a cloud infrastructure and all the management provided by cloud service providers that can resolve some issues like a backup or the failover, right? So this is the new platform. We already talked about cloud computing, and I think we will not cover open source in this class. But this is one approach. The other approach is fundamental change in the data model paradigm. You will introduce new types of data management system, so such as a NoSQL database, or utilizing something like data lake instead of data warehouse. The latter, the data lake, we will be talking about this in the second half of this course. And today we are going to talk about NoSQL database. And outside of data model change, we can also utilizing distributed computing against the single server approach. We are going to also talk about this later. Now, starting with a NoSQL. A NoSQL database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in relational database. So NoSQL is not an exact definition. Rather, it's a definition of what it is not. It's not SQL. As long as it's not relational, then it's NoSQL. So this is definitely due to the dominant nature of relational database, right? Even with all the NoSQL introduction, relational database is still the mainstream database management system. But there are places that the relational database cannot go, which is the niche market that the NoSQL data model try to conquer. These NoSQL databases are built for specific data scenarios that relational database has difficulty in dealing with. Originally, when people created the idea of NoSQL, they mean NoSQL. There's no place for SQL, at least in my domain. That was the original where the original name comes from. But at one point, people did think their NoSQL database can uh, replace or at least take over some of the relational database. But as we develop until this day, after so many years, it turned out that the NoSQL database has not lived up to this hope. Rather, it's becoming an ecosystem where SQL and the relational database is still at the center of data management system, but there are places where NoSQL models can fit into to resolve some issues that relational database is not capable of handling. So that's why people lately changed that to not only SQL. Still, you need SQL. But there are places the SQL is not the best choice. In this case, that's not only SQL. There are some two types of a common NoSQL scenario, right? And both are where we just discussed that relational database are not good at. One is a schemaless or relaxed schema situation. Relational database, as we mentioned, has a fixed schedule and requires the fixed schedule in order. NoSQL in these cases provides a flexible handling for especially for semi-structured data and unstructured data, such as column family, where you can have multiple columns consolidated without being predefined, or they can be optional, and they can be grouped into a larger column group. And inside this group, the columns can be flexible, can have the flexible order can be optional. There's also non-relational models, like data may be structured, but the schema is not enforced. So you can define some schema, but it's not required. Then there's a map, video, natural language, or hashtag, social interaction. All these can be somehow converted into a white column situation, white column data model. And there's a graphic relationship. When we see graph, this is in the computer science sense, where you have nodes and edges. Multiple nodes have a complex relationship among each other. So these are schemaless or relaxed schema situation where relational database is not good in handling. Then there's this ACID compliant, the non-ACID compliant choices where um, you will trade consistency for performance, scalability, or availability. We mentioned about like fraud detections before, and another example, a typical example, actually a more typical example is e-commerce. In the old days, when you think about like a trade or transaction, when you buy something, right, this is supposed to be a serious thing, and you have to make sure you have something to deliver. You have something in your warehouse, in your inventory. In order to do that, if there are multiple process orders coming in, ordering the same product, you have to do you have to place the order one by one. Make sure there are remaining inventories for the next order. But in the days of e-commerce, this is no longer the case. It's widely believed that the users these days are more tolerant to canceled orders due to unavailability. So if you go to some website, this actually happens to me myself. I want to first of all, I need to make it very clear that it's not Amazon, right? Because people can always ask me whether this is Amazon, but it's not Amazon. It's another e-commerce site where there was a great deal. I made a purchase of something, and a few days later, I received an email saying that, oh, sorry, we ran out of order. So will be definitely a huge issue, a huge accident, um, if this happens in a regular store, right? You cannot oversold. But in the days of e-commerce, people start to accept it. That is possible. If you think about this, what's the negative side of that? This gives me a very bad impression of that website, of course. But by selling me something, they at least they tried. I'm pretty sure they tried their best to estimate the inventory. And when it happens, that's accident on their side. But still, it's better than letting me go and buy that same thing from other company, or like from Amazon, right? So whether this is ethical or not, that's a different story. But basically, what I'm trying to say here is it's a different paradigm. Asset is not the only way of processing things. And of course, that can be, we talk about schemaless, we talk about ACID compliant. That might be both. These two can be combined together in the same situation. The common type of NoSQL, including like key value pair, white column store, document store, and graphic database. We'll talk about all these four one by one, giving a quick example. In the key value pairs case, it will be AWS DynamoDB. In the white column store case, it will be Bigtable. And document store case, it will be MongoDB. And graphic database, there's a graphic something called graphic database too. Starting with key value NoSQL, it's one of the earliest in NoSQL. What is happening, what is supposed to do is it's not considering the schema at all. Or in a sense, it will have the simplest schema. It only have two columns. One is key, one is value. All data are stored as key value pairs. Key must be unique in the table to identify each row or each entity or each document, whatever you call it. But with that key, you get the one and the unique value. So, and there, whatever is in the value, you interpret them. You can use a JSON format, a JSON document, so that you know what the schema is. Or you can just put audio, image, or you can also put some relational data string. But the key here is, from the database perspective, it only cares a key and a value. It's giving you a key and value pair, and how to interpret that is up to you. So the good thing about it is it's no complex query, and two, most of these k-value NoSQLs that are not ACID compliant or does not necessarily restrict you to ACID compliant. Most of the cases, in most of these key value stores, databases, you can choose between enforcing ACID or not. If you explicitly says that I don't want ACID, that's fine. If there's a parallel processing, the latter one will overwritten the previous one. If you choose to have ACID, it will do all of locking mechanism for you. So because of all these mechanisms, it's fast and it's scalable and usually it's distributed. One example of this key value NoSQL is AWS DynamoDB. As you can see, this is a screenshot from AWS. DynamoDB is a website. The AWS actually use DynamoDB in their own Amazon website. Their website was hosted by Oracle, and they spent a few years to replace the Oracle database with DynamoDB completely. So right now, the whole Amazon.com, the supporting database is DynamoDB, and for this reason, DynamoDB it certainly has a very challenge, very very solid customer example, implementation example, right? So you can always say if this product is used by Amazon.com, you can trust that this one is global, distributed, always available, fast, and can meet e-commerce and the most processing needs. So this is why Amazon DynamoDB is one of the most popular NoSQL databases. And how it works is you have this key. You can define every time you have for each table, right? You can create you can define a key and multiple values. Originally, it was just one value, right? But later on, they expanded. So now it's allowed to have multiple values. But basically, from one key, you get different values, and these values can these values all belongs to this row or instance, and some of the values, and we call it's a schema free in that some columns, some rows may not have this value. Like we have employee title for this row, but not for the others. And if you query based on employee title, you will only see this row. If you query by employee name starting with B, you will see this row and this row. So it's very flexible with the schema. And also you can define whether you want to do ACID compliant or not. This is key value, but if you think further down the line, I mentioned that for a flexible schema, you can put one value in the original versions. So in the early versions of this key value store, there's only one key and one value. And at that time, most people will put a JSON document inside this value. And for this inside this value, right, it will be key value pairs anyway. It will be employee name, Bill, employee title, IT engineer, etc., etc. And but if you look on top of that, look at the whole architecture of the key value. A key value is still is even the whole table, whole row is a key value pair. So if you merge this key value of the data structure into your value, you are getting a larger document, right? This is where where the idea of a document the document DB comes in. You don't need a key value pair defined. You just need to define one JSON document for each row. And the other way of looking at it is that if you can have multiple rows here, then you can basically for everything, anything, you can put the value here. Just only thing you need to do is to have a unique key for each combination, and that key can be calculated by doing a hash of all columns. This is called the white. This is possibly done by white column NoSQL. So what is a white column NoSQL? The name and format of each column can vary from row to row. But this is similar to NoSQL to DynamoDB, right? But instead of it's a natural extension of key value database, right? Key multi-value. But instead of defining a key on your own, it's the NoSQL table will generate the key based on the hash of the columns. So that means anytime you have some values, you can you can quickly identify the exact row of that value. So example is a Google Big Table. That's the big table database that behind Google Search and the Google Map. You think about like Google Map. Every point is a longitude combination of longitude and the latitude, right? And if you have a longitude and a latitude, from there, you will get a distinct list of objects, geographical uh, characteristics, and maybe like restaurants, gas stations around that area. So it's all identified by one single key of location. This is what the big table schema is. You will have row key, hash row, hash key, and then you have a huge. You can have multiple column families. Inside each column family, you can have multiple rows, multiple columns. I'm sorry, keep on saying. Inside each column family, you can have multiple columns. And the advantage of this is you can easily handle sparse column, which is very suitable for a map. How do you know whether you will have a restaurant or gas station around each point? You don't. So you would expect for some locations there will be the restaurant nearby or gas station nearby. For many of others, they won't. In this sense, you can have a column family of restaurant. If there is any, then put the value there. If there are 2 or 3 gas stations, then put all 3 stations here. But if there's nothing, then this column family can remain empty. So it's just an example, not necessarily how it is achieved. But the idea is you will be you will have different things, different characteristics of that of each row. Put that into either the put that into column families and group them that can handle as harsh columns. But then the database management system will hash the key for you. Anytime you want to look at the one location, you get longitude, latitude. The database management can quickly convert this into the table key and identify that row for you. That although it may have terabytes and like 1 million, 1 trillion rows in that table. But for each longitude and latitude, there's only one row. All it need to do is calculate that hash key, jump to that row. From that hash key, it can probably immediately identify where where this row sit at, and jump to that place and read it out, right? So this is the key is the most important thing in this situation is to determine the row granularity, how to calculate that hash key. That's a major design consideration both for performance and storage. This is how big a wide column schema is designed. Then we get to the document store ID, which we mentioned now, right? From the key value SQL, there comes the white column, which is to one direction. You have many different columns. And to the other situation is that we don't need a column anymore. We just consolidate the key value columns into one, forming a single document for each row. So there's no concept of a row anymore. Each JSON document will be one single entity inside one single instance inside the table or the store. Document stores NoSQL will store, retrieves, and managements all data points as JSON document. So they will do this through a JSON document-oriented information as known as semi-structured data. Usually, the semi-structured data is in JSON format. Each element is called a document. An example is the MongoDB. We will talk, but before we go into MongoDB, let's quickly talk about the GraphDB NoSQL. GraphDB NoSQL is like use the graph structure for semantic queries with nodes, edges, and properties. It can handle complex relationship. Example would be Neo4j.